So one of the difficulties in materials engineering is keeping track of all the information. And what's great about Ashby's book is that they give you a number of ways to keep track of all the data about materials. And the way they think of it is through imagining that they are trees of information. So this chapter 2 is about the family trees. And as you know, trees kind of have this configuration where, they come up from the ground. You have main branches off the tree, and those main branches also lead to smaller branches, and those smaller branches have even sub-branches off of that. And so in thinking about the information about materials, you can think of that along different types of trees. So go to in the Ashby text, page 15, and you'll see this image right here that has the different materials categories organized. Actually, if you go to page 16, you'll see a larger image with pictures of the different types of materials. And the way Ashby looks at it is he says, okay, you have metals as one sort of family tree of materials. There's ceramics and glasses, that's another main branch on this tree. Polymers and elastomers is a branch. And then something called hybrids, which is essentially what we call composites. And they usually consist of mixtures of the metal of these individual types of materials. A composite that you may be familiar with is fiberglass, which is a composite of glass fibers in a polymer matrix, and that is considered a hybrid material. So the way that these materials are organized are in a kind of tree, and if you look at page 17 in the text, you can see an example of this tree. Now this one is sort of laid out on its side, but Ashby shows that the materials can be broken down into the different families, and you might imagine that this is sort of like the tree. The tree is the materials tree, so to speak. This would be the trunk, and we have these different branches coming off the tree, and one of them corresponds to ceramics, one corresponds to glass, one corresponds to metals, polymers, elastomers, and hybrids, and so on. So these are the main branches of the tree, and off of these branches, or within, for example, one of the branches, metals, you have a number of sub-branches. He calls this the class, kind of using the biological classification system to apply to materials. So within the metals class, you have steel, copper alloys, aluminum alloys, titanium alloys, and so on. And within those alloys, there are actually different types, a subclass, different types of alloys, and these series numbers correspond to particular chemical compositions of these alloys. And even within a series, you can have distinct chemical compositions that are designated in a subnumber of the subclass. And within those, you can visit an individual set of attributes that describe, for example, what this alloy is like in terms of its density, mechanical properties, and other types of behavior, including ecological behavior like embedded energy and some toxicology information. So these material records are linked back through the tree on this pathway, as you can see. And this is the taxonomy of the material information that is used in the software that we use for this class, Cambridge Engineering Selector.